All right, problem number 3. So, 90% confidence interval produced this. So the point estimate is 90, and the margin of error is 30. How do we calculate margin of error? T star times the standard deviation, or the standard error, which would be S divided by square root of n, assuming a 1 sample here. So if we're working with the exact same data, our point estimate's not going to change. The standard deviation's not going to change. N is not going to change. What's the only thing that would change to go from a 90% to a 95%? T star. So we need to look at this critical value, T star, and see how that would be affected. So we can go to the formula sheet and pick any of the rows for degrees of freedom because we don't know what our sample size was here. But we just want to compare what's the difference between the T star for a 90% versus the T star for a 95%. So T star for 90% versus T star for 95%. Are they the same? No. If they're not the same, then one's bigger than the other, right? Which one is bigger? 95% has the bigger T star. So with everything else being the same, if I take a bigger T star and multiply it by my standard error, which stayed the same, what would happen to the margin of error? It's going to increase, it's going to get bigger. Look at those first two choices. What's the margin of error on choice A? 10. Is that bigger than the other one? So it can't be this. Look at choice B. Is that bigger than the other one? No. So it can't be this one. So we've got it kind of narrowed down to either C or D. I want you to look at these T stars for me. Because 70 is a lot bigger than 30, right? It's more than twice as big as 30. So I would need a T star that is more than twice as big as the other T star. Is there that much wiggle room, that much change in our T stars? No, they're not double. T star for 95% is not double the T star for 90%. If I'm seeing a change by more than a factor of 2, then my T star would have to change by more than a factor of 2. So process of elimination has led me to this as a likely outcome. It's bigger, but it is not stupidly bigger. What else would you guys like to look at? Yep. 8. Number 8, absolutely. A quiz question gives random samples of n equals 10 observations from each of 2 normally distributed populations. Tom uses a table of T distribution critical values and 9 degrees of freedom to calculate a 95% confidence interval for the difference in the 2 population means. Janelle uses her calculator's 2-sample T interval with 16.87 degrees of freedom to compute the 95% confidence interval. Assume that both students calculate the intervals correctly. Which of the following is true? Well, what happens when the degrees of freedom is smaller? It makes a wider interval, right? When the degrees of freedom is smaller, my T star is bigger, and so I would end up with a wider interval. So Tom's confidence interval would be wider than Janelle's confidence interval. Double check. Yep. We have not talked about how to do the intervals on the calculator. We will talk about that moving forward, but we're not going to talk about it before this test. We're just going to kind of focus on what we've learned how to do. So there is nothing on the test that you haven't learned in some form or fashion how to do. They're just talking here about what Janelle is doing, and so I know with a larger degrees of freedom, that's going to create a smaller interval. As n goes up, interval gets smaller. Yes? 19? Yes. 19 is the next to last question. We have 3 parts to this, A, B, and C. All right, so A. They gave us the interval. Right here is the interval. 317.64 to 394.56. When we know the interval, think about the interval on a number line. If this was on a number line and it was shaded on a number line, the point estimate is going to be smack dab in the center. So to find the point estimate, I'm going to take these 2 endpoints, I'm going to add them together, and then I'm going to cut it in half so that I can find what number is exactly halfway in between these two. So my point estimate would be 317.64 plus 394.56 cut in half. We end up with 356.1. Margin of error is not talking about a location on the number line. We're wanting to know how far apart are these two values. So you can do a couple things to find the margin of error. You could take the bigger number minus the point estimate. That would give you the distance. Or you can take these 2 endpoints right here. You can subtract them to figure out how far apart they are on the number line. And then you can cut that distance in half so that you go from the point estimate to just one end. So for our margin of error, we can do 394.56 minus 317.64 cut in half, which gives us 38.46. So there's part A. That much make sense? Cool. Let's go look at part B then. I know it's a confidence interval, but I don't know if it's a 90% confidence interval or an 80% or 95 or 99. I'm not sure, but I do know what the margin of error is. I do know what n is, and I do know what the standard deviation is. So I have almost everything needed to calculate the margin of error. To calculate the margin of error, we do T star times S divided by the square root of n. We know the margin of error is going to come out to be 38.46, so I can substitute that in. Equals, we don't know what T star is, but we do know S. S is 78.9168. Divided by the square root of, what's our n value? 26. And so I'm going to take and divide both sides by that horrible fraction, 78.9168 over 26, 78.9168 over square root of 26. It's going to cancel out over here, so all I have left is T star. And I would be careful putting this in my calculator. I would either make sure to put parentheses around my denominator so that I know my calculator is going to do it right. Or you could always use your rule for dividing fractions. It's the same as multiplying by the reciprocal. So you could do that also. But when you do this division here, you end up with 2.485-ish for your T star. And we know the degrees of freedom. What's the degrees of freedom? 25, because we have 26 minus 1. So I'm going to go to table B. I'm going to find 25 degrees of freedom, and I'm just going to start reading across that line until I find the number that is the closest to 2.485. Does anybody know what it is? 98%. All right, so part A is done, part B is done. Let's see if I have enough time for part C. Part C says, name 2 things the researcher could do to decrease the margin of error. Discuss a drawback of each. What's one thing they could do? We could decrease the confidence level. What's a drawback to that? Confidence interval may not capture the true mean. Because more of the confidence intervals that are created in this way don't capture the true mean. What is something else that could be done to decrease the margin of error? Increase the sample size. So we could increase n. What's the problem with that? More time and money. And I don't know about you, but they ate 26 Tootsie Pops, and they were counting the number of licks, so you couldn't just stick it in your mouth and go, which after 26 Tootsie Pops, I would be sick of Tootsie Pops. But you can't just sit there and do that. You have to go 1, 2, 3, 4. It's going to be a lot more time if you increase that sample size. You guys have any last-minute clarification questions? I don't have enough time to do any more off the review, but anything else that you would like clarified for you? Test is Tuesday, which is the very next day I see you, and then we will start the next to last chapter.